maybe. 5.4, factor and solve polynomial equations. Okay, so in the last chapter, which I know that was, a little while ago now, we had some different types that we learned about for factoring. So I'm just going to write them down with one little example for a refresher. Alright, so a general trinomial, okay, just a basic one that's not a special type. Need something like 2x squared minus 3x minus 20, which after doing your arch method and everything would factor into 2x plus 5x minus 4. Okay, obviously you'd have to do some work for that, but that's what it would basically factor into. Okay, we learned about the perfect square trinomial, which was a special type. So we had x squared plus 8x plus 16. So this was the one that you have the first term squared, the last term squared, and the middle term is 2 times a times b. Okay, so this factors into x plus 4 squared. We had a difference of squares. Something like 9x squared minus 1. This is the one that factors into 3x plus 1, 3x minus 1. And then the last one, we don't necessarily call it this all the time, but it's just basically factoring something out of it as a common monomial factor. So if you have something like 8x squared plus 20x, we can pull a 4x out of that because that's the biggest thing we can pull out of each of them. So pulling out a 4x, you're left with 2x plus 5. So that's just a little review of the different types that we had from the last chapter. Alright, so then definition, a factorable polynomial with integer coefficients is factored completely. That's the term we're looking at. If it is written as the product of unfactorable polynomials with integer coefficients, okay, so just a little quick example. Something like 2 times x plus 1 times x minus 4 is factored completely. Okay, it can't be broken down anymore. But something like x squared minus 4 is not factored completely. Because it can be broken down into x plus 2 times x minus 2. And then once it's broken down like this, it is factored completely. Alright, so we have a couple more special factoring patterns now for cubic things. And thank you to Logan last year. I have a way for you guys to remember these ones a little easier. So special factoring patterns. So the first one is the sum of two cubes so this is a cubed plus b cubed, and this would factor into a plus b times a squared minus ab plus b squared. So this one's a little nicer because you don't have to worry about numbers other than, like, obviously if the a or the b term is a number, then you obviously have numbers. But otherwise, you don't have any extra numbers like how with the formulas from the last section we had, like the 1, 3, 3, 1 pattern that went with it. So that's the sum of two cubes. And then we have the difference of two cubes. So a cubed minus b cubed is a minus b times a squared plus ab plus b squared. Okay, so the trick to remember this is SOAP. Same, opposite, always positive. Okay, so when you look at these signs up here, okay, this one is a plus b cubed. So the first sign here is the same sign, so it's positive. Okay, and then the next one, okay, this was positive to start with. The next sign is opposite, so this one's minus AB, and then the last one is always positive. Okay, so then down here, this one was negative, so we start with the negative, then opposite, so it becomes positive, and then the last one is always positive. Okay, so that's kind of a trick. If you remember what the pattern is, then you just have to remember same, opposite, always positive, and you can go back and put your signs in afterwards. Alright, and we have one last thing that I'm going to try to just fit here at the bottom. Factor by grouping. I think we've done this before, or you should have done it at least in Algebra 1. But so if you have something like RA plus RB plus SA plus SB, okay, then that would, factor by grouping basically just means group two things together and pull out something they have in common. So I'm going to pull out the R from the first one and an S from the second one. So R times A plus B plus S, taking S out of this one, times A plus B. And then we rewrite it as R plus S times A plus B. Which you've done that before. I know you do it without realizing it when you're just factoring in general. So, but just like a little refresher on factor by grouping.